functions. We've actually kind of been dealing with piecewise functions, or we've dealt with a certain piecewise function since I think it was like day one. I think the first day we had a problem where they talked about putting kids on the school bus, and we had to figure out how many buses we needed. And we decided that we couldn't have half of a bus, so when we went from one, however many kids we needed to get another bus, I had to go to a whole full bus. And we did our step function from there. Well, step functions are actually a type of piecewise function. What we're going to look at is, first of all, if it is a piecewise function, we should be able to write some sort of equation for it. So like it says on there, this is the graph for this situation. It says that the phone company is going to offer a monthly voice phone plan where you pay $40 for the first 450 minutes and then 45 cents per minute after that. And again, that's what the graph is representing. Like it says on there, this is a piecewise defined function with many pieces. What we're going to try to do is we're going to try to come up with an equation for this, and then after that we'll look at, well, what's the domain and the range for it? Well, here's how we're going to focus on a piecewise function. Just like the name says, it's really made up of different pieces for that function. So for each piece, we're going to think about, well, what would be the equation of that piece? So on this one, we have a bunch of vertical lines, but I'm going to start at this part of it. Not vertical lines, horizontal. And if I asked you just that red piece there, if you were to give me the equation of that, what would the equation be? Well, anytime we have a horizontal line, that means we have a constant value. And if it's a constant value, in this case, that constant value was $40. So if I just ask you to write the equation of this, I might say, okay, well, this is y equals 40. Well, that's kind of what I'm going to do with my piecewise function, except, first of all, I'm going to call this f of x. But f of x doesn't equal 40 the entire time, so I'm going to list up here when it equals 40. So what I'm going to say is, I'm going to say f of x equals 40 if, and then I've got to tell them, all right, well, when does that happen? Which x values give me a value of 40? Well, how long were they going to charge us $40 in this situation? Where does it start? Where does it end? For the first how many minutes?
For the first 450 minutes.
Right. So I'm going to say f of x is equal to 40 if x is between 0 and 450. Then it changes. Well, the next portion is this portion. And they said that they were going to charge us, was it 50 cents? I don't remember, 45 cents. So they're going to charge me an extra 45 cents. So this portion now would be $40.45. And that's the next part of my graph. So the next part of my graph is 40.45. When is that going to be true? Well, it's going to be true when we go over that 450. And it's per minute, so until we get to 451. And then that pattern continued. So we had to pay an extra 45 cents, and now it's 40.90. That happened for the next minute, so greater than 451, less than equal to 452. And for this graph itself, we had 3 more of those. So we had one when 45 more cents, 41, 35, 41.80, and 42.25. So those would all be considered part of my function. So I would list all of those in my equation. Now, the reason I had to list all these, like the 450 is less than x, which is less than 451, my graph says I get all those points in between. So that's why I want to include those. Like if I have 450 and a half minutes, well, they're going to round it up to 451 when they charge me. And so this might be the way we would write, and since all of these go together, a lot of times you'll see these kind of curly brackets to show that, okay, this is my entire piecewise function. So just like the name says, we're going to take each piece and we're going to make an equation for it. Now, they also asked us for the domain and range for this one, which if we stick to just the graph, let's think about what our domain is. Well, domain was the amount of time, so we knew we could go from 0 to what was the largest value we talked about, x, y, in our function here. 455. So based on the graph itself, now we know the situation, I can keep adding more and more minutes, but for the graph itself, that would be our domain. The range, well, the range would actually be all these values that we listed earlier, because those are all the different charges we could have. So our range would actually be just a list of those values, the $40, $40.45, and so on. So when we look at a piecewise function, we're going to look at each piece, and we're going to come up with an equation for each piece. Now, for this one, those equations weren't too difficult. They're all just full numbers. They were all horizontal lines. Most of the time when we have a piecewise function, though, they're not just going to be a step graph or step function. They're going to be made up of different types of graphs or different types of functions. All right, so here's what I want you to do for that graph that's on there. This is still a type of a piecewise function because even though it's all connected together, it's not just a line or a curve or a consistent function there. But start out with what I like you to do is I like you to fill in the table for the values. So when they say that x is -4, find out what the output is according to the graph. So when x is -4, we had an output of -2. And continue on filling in the rest of the values. All right, so go ahead and fill in the table to start with using those inputs that they give. All right, so here's what we're going to try to do. We're going to try to see if we can come up with an equation for this piecewise function. And we'll kind of check our equation with the values that you had in your table. So if I start out with, if I read this graph from left to right, it looks like we started out kind of like last time. We had this horizontal line that existed. So what was your output for that one? What was that horizontal line? -2. So that's going to be the first part of our function, is the fact that we had f of x equals -2. Now, it remained at -2 for these x values. It started at -4, and it stayed there until -2. So I'm going to say that the output's going to be -2 if the x values go from -4 to, it should be -2, to -2. Well, then our graph changed. We had a different situation going on. So it looks like on our graph, we now had this portion where we had another type of line. It just wasn't horizontal anymore. Well, we know how to find the equation of a line. We know we need the slope and we need the y-intercept. So if we look at this one and we look at, first of all, the slope. Well, it looks like I went down 1 over 1, down 1 over 1. So it looks like I have a -1 for our slope. Our y-intercept is nice and neat on this one. It's at -4. So it looks like this function is -x minus 4. Well, where does that happen? From where to where? Think about x values. I think we went over too far. Where did my green line start? -2. Now, I've got a little bit of a dilemma here, because we said we had a function that we're dealing with. And if I have a function, every input should only have one output. Well, is that still happening here at -2? When I look at -2, I have -2 listed in two different functions. Is it giving me two different outputs? No. What's this one say? If I put -2 into this one, what should I get for an output? -2, because all of them were -2, right? If I were to put -2 into this one, what should I get for an output? What's the opposite of -2? 2 minus 4 is -2. So I still got the same output. So I still have a function. So I'm okay there. Had I got two different answers here for that same value, that would have been a problem, because that would not be a function. However, if somebody gave me -2, I got to know, am I dealing with this function, this part of the function, or this part of the function? So usually the conventional way of writing it is, instead of including -2 in this one and in this one, I just choose one of them to deal with. And what I mean by that is, instead of saying this first one is equal to -2, I may just leave that off. Or if I decide to make that one equal to, the other one is going to be just less than. So there's no real rule to which one you use, but we're not going to use them for both. Usually what I do is I leave the first one, and then I make it equal to for the second one. But that doesn't mean it has to be done that way. You just technically want to avoid having it for both. All right, the next part of our graph may be a little bit tougher to figure out what's happening. But we've got this function here. Well, it kind of looks like it's half of a parabola, which means if I were trying to come up with an equation, I'm going to have an x squared in there somewhere. Well, for this one, instead of thinking about what the function is right away, let's think about what values I looked at here. On this one, we went from +1 all the way to +4. And again, I got to make a choice, so I'm going to make this one just 1, so I'm going to include it on the second. And eventually I know I'm going to have the 4, so I'm going to leave the 4 just less than. Well, if you go to your table, let's see what values we have in the table for those x coordinates. So for when x is 1 all the way through 4, let's look at our outputs. Well, what was the output when x is 1? What did you get in your table when x was 1? What did you get? 2, 3, and 4. Okay. So what we're going to try to do is we're going to try to figure out, all right, well, if I have this set of ordered pairs, can I find an equation for that set of ordered pairs? Well, again, it kind of looks like a parabola, so maybe we're going to think in terms of, well, do I have an x squared situation? Well, if I were to square 1, I'd get 1, but I really need a negative 5. So that would be like subtracting how much? 6. So I'm going to test this out, x squared minus 6. Maybe it works, maybe it doesn't. Well, if I square 2, I've got 4 minus 6 doesn't give me negative 4. 3 squared is 9, minus 6 doesn't give me negative 1. So it doesn't look like I can quite go to this. What might be another way that I can figure out what my equation is? And then again, I can test it with my points. But okay, because it looks like I've got the vertex here, right? So it looks like the vertex is at 1, negative 5. So you might think of it, okay, I've got this situation. Well, let's test that one out. Well, if I put 1 in, we got 1 minus 1 or 0, squared is still 0, minus 5 is negative 5. So far, so good. If I put 2 in, I've got 1 squared minus 5 is negative 4, so 2 for 2. Put 3 in there, I get 4 minus 5 is negative 1, and I'm starting to convince myself that looks like it's okay. So I didn't have any stretching or compressing going on there. So that portion of my graph, I could maybe say this is x minus 1 squared minus 5. And again, that would happen from positive 1 to 4. And then we got the last part. The last part was the horizontal line again. And that was when the value was 4. What it goes 7. And so if I were writing an equation for that piecewise function, that would be the equation I would come up with. And again, I can test it by looking at the table and seeing what values we have in there, making sure they match. So piecewise functions look pretty tricky here, but it's really just looking at all the different pieces and looking at graphs that we've already done before. Well, here's what you're going to try to do today. Now that we have a little bit of an idea of what a piecewise function looks like, we're going to look and see, well, can we move it around like we have all these other graphs? Can we shift it up and down? Can we stretch it? Can we compress it? All that sort of thing. So on the back of that sheet, you have 4 graphs there. Now, all 4 graphs that are on there right now are the same as this graph right here. Okay, so that's your original graph in each case. But what you're going to do is you're going to make some changes to those graphs. Well, you'll notice that they gave you a table beneath each one. And in the table, for this first one at least, it has x and then it has f of x. But you don't have to relist those values. Those are the ones that you just found a second ago. And those are all the ones that are plotted up here. So you don't have to fill in that one. But you do want to fill in the last one, because the last one says, all right, we want to now do the opposite of whatever f of x was. For instance, originally at negative 4, you had a value of negative 2. I'm just going to do the opposite sign of that. So now I have a positive 2. Once you get this last row completed, you're then going to plot those points. So I would plot the point -4, 2. I plot the point -3, whatever it ends up being, and so on. And then we'll compare that graph to the original. The second one, you'll be taking half of the original output. The third one, you'll be doing 4 more than the original output. The last one seems to cause people problems, so let's go through this one as far as what they're wanting you to do, because it looks a little bit different than the others. In this one, what they want you to do, first of all, they say, here are some x values. Now, those x values are different than the ones you had originally. Then it says, well, just take x minus 4. So in other words, you're just going to subtract 4 from each of those values. So you're not plugging them into anything, you're just literally subtracting them. So that's really what that row is. Then they're saying, go back to the original function. So the one that we dealt with on the front. Make your input x minus 4. Well, the input of x minus 4 is what you just found in that row. For instance, they're asking you to find f of -4 from the original graph. And f of -4 in the original graph was -2. They're asking you to find f of -3 from the original graph. Well, the original graph, -3, gave you -2 as well. And you'll continue on finding those values. Here's the part that usually confuses people. When you graph your new graph, you're going to graph the x's and these outputs that you come up with here. So it's going to be a different graph because you're using different x values than what we did before. So if you get to that one and you get a little bit confused, I'll help you out with that. All right, I'm going to have you work on these in your groups. Looks like we're a little thin in one group. But I'm going to have you work on these. So compare as you go. Make sure that you're getting the same graphs. But also ask yourself, all right, is the same result happening now that I'm used to seeing when I have that sort of situation on the change? Okay? And we'll see what your results are from there. So if you would, go ahead and move together in your groups. Brock, I'll have you work this through. Everybody else go. After you fill in your tables, go ahead and graph those new ones. See what sort of changes took place.
The opposite of this.
Yeah, do the whole thing, so you can get your output.
Then it's minus.
Or the fast way. You're in the output.
Oh.
Eric, if you remember, see if you get the same graph. I put the first graph up on the board, but should have had that. On that first one, if I throw that negative out in front of my function, what would I expect it to do to the graph? What do we say a negative out in front was going to do? It's going to flip it which way? Over the x-axis, y-axis? X-axis. Did it? Yeah. It took the original and reflected it over the x-axis. So we got what we expected to. The second one, where they said half of f of x, what would we expect to happen if I have a half out in front? Stretch or compress? Compress. Did it? Did we take the original and compress it? Yeah. Okay, so we got the same thing we always have for every other function. The third one's got f of x and then plus 4. So what would we expect to happen if we add 4 to it? Move it up 4. Did that happen? Yeah. So everything that's happened on every other function happened with the piecewise function. So when you get to the last one, when they ask you to find f of x minus 4, well, if I have x minus 4 in parentheses, what would I expect the graph to do? Move which way? To the right. So let's make sure that this happened on this function. Again, it was a little bit confusing on the setup, but essentially what ended up happening here was you got all the original values from the original function. So this bottom row should have had the same values as what you had earlier. So all those outputs ended up being the same as what they originally were. However, the x values were different. They were 4 more than what we originally had. So we now have 0, negative 2, our first one. And we have 1, negative 2. 2, -2, and so on. So we ended up with what we expected to have happen. And that was everything got shifted over to the right 4 spots. Where am I here? And so that's what our graph looked like. So just reinforcing that idea of, doesn't matter what kind of function we have, or if it's a non-function, we can still do a lot of the shifting the same way that we have before, or compressing, or stretching, whatever the case may be. Honestly, we're not going to do a ton with piecewise functions this year. We'll still do a lot of step function work, but in general, we won't do a ton of piecewise functions. Next year in pre-calc, you'll do a lot with piecewise functions. So that's why I want to kind of give you an introduction to that. So the sheet I'm handing out right now really has the 3 basic things we have to do with piecewise functions. And so again, I just want to give you an idea of what they may look like. So next year you can say, oh yeah, Mr. White said something about that last year. I don't remember what he said, but you know he said something. Don't say that very often, but you don't remember what I said. But let's see what it has on here. The first thing we may have to do with piecewise function is actually graph it. So they gave us this piecewise function. They said f of x is equal to 3 plus x from -8 to -3. It says it's equal to 3 from -3 to 0. And then it's equal to the square root of x for all the values greater than or equal to 0. So there's different ways you can attack it. You can attack it in terms of what the graph looks like. In other words, if I have 3 plus x, I know that's really a line. So I could graph it in terms of it being a line. Or the way I like to do it is I like to just think about, okay, here are the values I need. What are the outputs for those values? And then in the back of my mind, I know it has to be a line for that part. So what I might do is I'd say, okay, well, the first value I know I'm going to use is -8. I'm going to plug -8 in. Well, if I do 3 plus -8, I now have -5. So this doesn't carry over very well. So that's my first point. Then I'm going to plug in -7. Well, if I plug in -7, I've got -4. Plug in -6, -5, -4. And now they kind of they did give me the equation. They said that it's less than -3. So I'm not going to put a solid dot at -3. I'm going to put an open dot on that last one. And I know this is the first part of my piecewise function. Well, then the next part says I'm going to have an output of 3, starting at -3, and going to almost to 0. So at -3, I'm going to have an output of 3, and it's going to stay there until I get to 0, where I'll put an open circle. Then it says I'm going to have the square root of x for all the values at x or larger, or at 0 or larger. So if I plug 0 in, the square root of 0 is 0. So I've got that value. If I plug in 1, the square root of 1 is 1. The square root of 2 I know is not nice and neat, so I'm actually going to go to the next perfect square. The next perfect square would be 4, so the square root of 4 would be 2. And I might get one more value, so I'll go out to 9 because it's a perfect square, and that's going to be 3. And we already have an idea of what that looks like, but that's going to be our square root graph. Now this time I'm going to put an arrow on there because it says all the values greater than or equal to. So that would be an example of starting with a piecewise function and then actually graph it. Something else that you might be asked to do is evaluate a piecewise function. So they give you the piecewise function, and then they want to know on this one, well, what's f of -3? So what I have to do is I have to decide, well, which part of my function would -3 fall in? Well, in this example here, that would be in that case where x is less than or equal to 0. So the function I'm going to use is x plus 6. So to figure this out, I'm going to plug in -3, and so my output will just be positive 3. Which part of the function would I use to figure out what f of 2 is? The first, the middle, or last? Middle. They said that's when x is going to be equal to 2, less than or equal to 2. And this one, we don't have to plug anything in because they said the output is -4. So with piecewise functions, you may be asked to graph them. You may be asked to evaluate them. Or you may go in reverse, where they give you the graph and they ask you to find the equation of the graph. So this is like what we started with. So let's see if we can find the equation of this one. Well, it looks like this one only has 2 parts. It's got this part here. It starts at -3. It goes up to 2. And then it has the part that goes from 3 to 6. So I've got those 2 portions I'm going to try to find the equation for. Both of them are lines. The nice thing about the blue line is it actually hits the y-axis. That'll make it a little bit easier. So really all I need to do is figure out what the slope is of that one. What is our slope of that one? 2/3, is that right? That's right, on the 2/3. So that function would be 2/3 x. Went through at -1, and that started at -3, and went to +2, except that there's no concern, so we'll include it. Then the other part, well, this one we can find the slope of pretty quickly. Looks like our slope here is we went up 2 and over 1, 2, 3, 4. So it looks like we have a half, and it's negative going downhill. So we know it's a -1/2 x. Right now it's not crossing the y-intercept or y-axis, but we could continue that path. So if we go up 1 and to the left 2, I find out it actually hits over here at +6. And that happened from 2 until we got to 6. And so that would be the question.
Wouldn't the slope of the first graph just be +2?
It could be, I don't know. I couldn't see them all on one. Yeah, it is, sorry. Thanks. So again, just really an introduction to piecewise functions right now. Step functions are ones that we've done a lot with, but just throwing in a little extra today. Again, though, thinking about the transformations, they remain the same as all the other ones. All right, well, I'm going to give you time now to start working on Wednesday's assignment. Piecewise functions actually finally, this seems like the never-ending chapter, but that finally wraps up chapter 2. So On Wednesday, we're going to just kind of do some practice, not necessarily with piecewise functions, but just stuff in general for chapter 2. And then on Friday, we're actually going to go ahead and start the next chapter. We'll do a couple days in chapter 3 before we actually take our test for chapter 2. So next week, I'll let you know the exact date for our full chapter 2 test. We've done a mid-chapter 2, but our full chapter 2 test will be probably next Thursday, but I'll let you know for sure in the next couple days. But here's the assignment that I'd like you to do for Wednesday. On 175, you only have to do part B. So those are Wednesday's problems. I'm giving you a pretty big chunk of time because there's a decent number of problems there. I updated grades at least for the first 2 assignments. So if for some reason you didn't have one turned in that you meant to turn in, make sure that takes place. I have not looked through the one that was due today. Make sure that's turned in as well.